Okay, so I'm going to start solving this guide of exercises for about kinematics and integrals from exercise 04 because I finished my last video. I mean, we already did the first 3 exercises of this guide. So exercise 4 says, a particle P moves along the x-axis. The velocity of P is v meters per second at time t seconds, where v of t is 4 plus 4t minus 3t squared for t between 0 and 3. When t0, p is at the origin, this is a given, okay? So they are saying that if we have the x-axis and the particle starts here, then the definition of the origin is here, okay? So this here is the point O, the origin. So find the value of t when p reaches its maximum velocity. Okay, so this exercise 4 is thought to be done without the calculator, okay? So without any technology. So first I'm going to solve it that way, and then I'm going to solve it with the GDC so that you can practice how to use it, okay? But first, without any calculator. Right, so we know that this is the function for the velocity. So if we understand how to graph this function, what is this? This is a quadratic equation, quadratic function with the main coefficient -3, so negative. So this is what we generally call a sad parabola. So this will be something like this, or like this, or like this, I don't know, but it will be a parabola like this, right? So concave down, so moving down, let's say, and the vertex is going to be the maximum value. So to find the value of t when p reaches its maximum velocity, since this is velocity against time, we need to find actually this vertex, okay? This is the maximum velocity. So to find the value of the vertex, we need to, we should remember the formula, but just in case, we have it here. If the function f of x is a quadratic, ax squared plus bx plus c, then the axis of symmetry, which is the same as the x of the vertex, is minus v over 2a. So we need to understand that x of the vertex is minus v over 2a. So now we should know which are the values of b and a. So b is the one that is multiplying the t, so 4, so minus 4, over 2 times a. And a, as we mentioned before, is the main coefficient, which is minus 3. So 4 over this, we get minus 4 over minus 6, which is negative over negative, it's positive, so 2/3. Okay, and as we see in the answer, t is 2/3, okay, of a second. Great, so this is the formula. Great, so 4b says, show that the distance of p from O at this time is 88 over 27 meters. Okay, so now what we need to understand is that distance here is not the total distance traveled. What we are being asked is, let's say here is the x-axis, here's the origin, and the particle started here, then it doesn't matter how was the movement of the particle, okay? If it was like this, the important thing is that if the particle ends here, okay, this is the distance, okay? This distance would be negative, and if the particle was here, then this would be positive, but the important thing is that the distance from P from O is the displacement, okay? This is what we are being asked. So we are being asked the displacement. So now what we need to understand is that the displacement the displacement between the time 0 and the time 2/3, right? When we are being asked, is basically, s of 2/3 is going to be the integral between 0 and 2/3 of the velocity, okay? So we have a definite integral here, a definite integral. So, okay, so this is going to be basically the area of the graph. If we have the graph of the velocity, it will be something like this. And here, when it is maximum, this is 2/3 of a second. Okay, so we are going to find this shaded area. Okay, this is the integral between 0 and 2/3, which is the displacement of the particle. Okay, so great. So we have that, and to integrate. Wait, I'm going to erase. Well, I'm not going to erase. Okay, so to integrate this formula, we have that the velocity is 4 plus 4t minus 3t squared. So we integrate, the 4 becomes 4t, then plus 4t becomes plus 4t squared over 2. Okay, this is how we integrate. And then minus 3t cubed, right? Because we have a square, it becomes cubed over 3. Okay, because of how it is, because of how we have to integrate. And this, we need to evaluate it in 2/3 and 0. Okay, this is because of, this is because this is a definite integral, it's not indefinite. Okay, so we need to evaluate. Great. So we get these limits, and now let's evaluate at 2/3. So at 2/3, we have 4 times 2/3 plus 4, well, 4/2 is actually 2, right? So we have 2 times 2/3 squared minus 3/3 becomes 1, so minus 2/3 to the power of 3, okay? So this is equal to 4 times 2 is 8, so 8/3. Then here we have plus 2/3 squared is 4/9, so 2 times 4/9, it is 8/9. And here we have minus 2/3 to the power of 3. This is basically 2 to the power of 3 over 3 to the power of 3, which is 8/27. Okay, so we get minus 8/27. Okay, now we move on. The common denominator will be 27, and then we have this. To move it to a denominator 27, we need to multiply by 9, right? So 3 by 9 is 27, so 8 by 9, it is 72. Then plus the 9 should be multiplied by 3 to reach the 27, so 8 times 3, it is 24. Minus 8, okay, because it's the same. So 72 plus 24 is 96, minus 8, it is 88/27, okay? But now we didn't finish, right? Because we need to evaluate this integral at 0, okay, the lower limit. But basically 4 times 0 plus 0, sorry, 0 squared, 2 times 0 squared, minus 0 cubed, it is basically 0, right? So this is 0. So the answer is this minus 0, which is 88/27. Okay, and this is the displacement after the first 2/3 of a second. Okay, so that's the answer, and here we showed it. Okay, we demonstrated it. So that's for B. Okay, you can check the mark scheme as well. Sketch a graph of B against T, clearly showing any point of intersection with the axis. Okay, so basically we need to, first of all, the function was V of t is 4 plus 4t minus 3t squared, okay, from 0 to 3. So the only important things are from 0 to 3. So when t is 1, let's find v of 0, v of 1, and v of 2, and v of 3, just, to put some points, okay? And v of 3. So v of 0 is 4 plus 0 plus 0, which is 4. Okay, so we start here at 4. Okay, at 4, we have this point. V of 1, when when t is equal to 1, we have 4 plus 4 minus 3, which is 5. Okay, so when when x is 1, we are at 5 here. Okay, so here we have a point. Then when t is 2, we have 4 plus 8, 12, minus 12, we have a 0. Oh, actually, this is a root, right? I didn't know. But so when x is equal to 2, we have a root. And then when x is equal to 3, we have 4 plus 3 times 4, which is 4 plus 12 minus 3 times 3 squared, which is 27. So the velocity is going to be minus 11, if I'm not mistaken. So in minus 11, we will have this last point. Okay, let's say this is minus 11. So we have this point. Okay, so the graph, we know that when t is 2/3, we have the maximum, more or less here. So this will be something moving like this and then like this. Okay, something like that. Great. So we are showing the root here, we are showing the y-intercept, and we also added some points. So this is basically the sketch. We could find out what's the velocity here at the maximum and write it down, but I won't do it, okay? But just in case, you could, okay? And I mean, this is 4 marks, so be aware of this, right? So for example, this, I mean, the y-intercept may be 1 point, the root may be another point, the maximum may be another point, and actually maybe showing the y value of the maximum could be 1 more point, okay? So just for you to know. How do we find the maximum? Just replacing t by 2/3 in the formula, okay? I won't do that. Great, so that's for C. Now, okay, well, we have here the answer, actually, right? So the root is at t equals 2 and so on. Okay, great. So, I mean, here actually you can see what gives you the marks, right? So correct x-intercept, which is the root, is 1 point. The valid, I mean, solving the root with the formula is 1 point. Correct domain from 0 to 3 is 1 point, and that is very important. Okay, starting at 0, 4, which is the y-intercept, this is 1 point. And then the 3 must be clearly indicated, it says, okay. And then vertex in approximately correct place, okay, so in 2/3 here, that is another point, and the velocity should be greater than 4, okay? So this is how marks are awarded. So for this says, find the total distance traveled by P. And now that we have the sketch, this is very important, right? Because the distance traveled is this area plus this area, okay? Now the thing is, if we integrate from 0 to 3, this is going to be added up. This is positive, but this is negative, okay? And we do not want this to be negative because this is distance traveled. So we need this to be positive. So what we need to do is first find this area, this shaded area, then find this shaded area with, I mean, that will be negative, but we should take the positive value of this and add it up with this one. So let's integrate. So we need to integrate the integral of 4 plus 4t minus 3t squared between 0 and 2, okay? And before we had calculated, I will do it with another color, we had calculated the area here, right? But we were still missing the area here, okay? So we could do it, I mean, with 2 ways, either calculating the missing area and adding it up to the 88/27, or just calculating all at once, and I will do that, okay? So the area here at the beginning is, again, 4t plus, plus 2t squared, as we already said before, minus t cubed, evaluated at 2 and at 0. Evaluated at 0, we already know we have a 0. So the answer for this part, this is going to be equal to 4 times 2 plus 2 times 2 squared minus 2 cubed. And this is 8 plus 8 minus 8, which is 8. Okay, so at the beginning, the particle in the first 2 seconds moved 8 meters to the right. Okay, and it was here. So this is the total distance traveled in the first 2 seconds. Okay, and then we need to do the same, but evaluating this at 3 and 2. Okay, and subtracting the at 2. Okay, so the integral between 2 and 3 of this function of 4 plus 4t minus 3t squared is 4t, and again, right, 4t plus 2t squared minus t cubed, evaluated at 3 and at 2. Okay, so at 2, actually, we already know it's an 8, right? So we need to find out this value. So this value is going to be 4 times 3 plus 2 times 3 squared minus 3 cubed. And this is 12 plus 18, if I'm not mistaken, minus 27. And this is 30 minus 27, which is 3. Okay, 3. And this, we already know it is 8. Okay, I mean, because we already evaluated it here, right? So the distance traveled here, the total area is 3 minus 8, okay? Remember that these limits, I mean, we evaluate the function and we need to subtract them. So 3 minus 8 is equal to minus 5. So what we know here is that from second 2 to second 3, the particle moved 5 meters to the right, to the left. So it finished being here. But since we want the total distance traveled, it is not going to be 3. The answer is going to be 8, the first 8 meters, plus 5. So the total answer is 8 plus 5, which is 13. This is the total distance traveled by the particle in the first 3 seconds. Okay, I'm going to erase. You can go back to the video if you want, or pause it if you want. And if we check the answer, you can see everything, and the answer is 13. Okay, this was 5 marks. Right, so this was exercise 4 done without the GDC. Now I will do it with the calculator, and then I will finish the video and solve the other 2 exercises on another one. Okay, so how should we have done this exercise with the GDC? So one way is, we have this, right? So let's graph this function. So we can graph 4 plus 4x minus 3x squared. Okay, we can graph this. Remember that the important parts are from 0 to 3, so we only need to watch that. And let's watch, just in case, from minus 10 to 10. Okay, this is something that I generally do, and it's if this is not enough, I can change it to minus 20 and 20, or 0 and 20, or whatever. Okay, exit and draw. So now we can see this. Great, we can see it perfectly. Okay, great. So find the value of t when p reaches its maximum velocity, basically G-solve max, and we get the value 0.666667, which is 2/3. Okay, so just for you to know, this is 2/3. Great. So show that the distance of p from O at this time is 88/27. So the only thing we need to do is first understand that we are asked the displacement, and then G-solve, So G-solve f6, and now integral between 0 is the lower bound, and 0.66667, basically. And the answer is 3.259. And if we go and check what's the value of 88/27, we get 3.259, so it's the same, right? So, this is how we can calculate the distance. So 3.259, and it's the same as we had here. Great. So then for C sketch, of course, it doesn't make sense with the GDC, right? Amazing. And then for this says find the total distance traveled, then we only need to do G-solve the integral between, as we said, 0 and 2, right? Oh, actually, first we should have found the root. Okay, sorry. So I am going to do that. So first, G-solve root. The root is at x equals to 2. And now that we know the root, we go and G-solve the integral, as we did it before, between 0 and the root, and we get 8. Okay, so 8 meters is the amount traveled, is the total distance traveled in the first 2 seconds. And then if I'm doing this just so that it gets unpainted, right? So I'm going to here, and then again here, and I got it unpainted. So now I need to to solve with the G-solve the integral between 2 and 3, and we get -5. Okay, so the total distance traveled is 8 plus 5, which is 13. You can check with the GDC that if you were to find the total integral between 0 and 3, then the answer is 3. Okay, why? Because the answer is 8 minus 5, which is 3, and this is the displacement. Okay, not the total distance traveled. Okay, so that's that for exercise 4. I'm going to end the video here and continue in another one.